Hi. So I have already uploaded these questions in my shorts video. So now what is the answer? What is the not answer? What is the reason behind these two questions? Now see, here it is the statement is the melting point of para-dichlorobenzene is high than ortho or the meta isomer. Now why so? Now if you watch carefully, you will see this this para-dichlorobenzene, this para isomer, it is more symmetrical in nature. Okay, like it is having a better symmetry. It can be symmetrical in the sense it can fit very closely in the crystal lattice. So it can fit closely in crystal lattice, right? Now if it can fit very closely, suppose these are this symmetrical like this para isomer, so they can fit like this, so there is hardly any gap or hardly any vacant spaces between them. Okay, so they can fit very closely in the crystal lattice. So now they have very strong intramolecular attraction, they have very strong intermolecular attraction. So when there is more intermolecular force of attraction than ortho meta isomer, so melting point means you are melting. So during the melting or dissolution process, when the crystal lattice breaks, a very large amount of energy you have to put, otherwise they won't melt, they won't dissolve, right? That's why the melting point of this para isomer is greater than this ortho or meta isomer. Okay, now the next question, that dipole moment, mu means dipole moment. Okay, now why the dipole moment of cyclohexyl chloride is greater than chlorobenzene? So here are two reasons. One reason is, see in this cyclohexyl chloride, and here this is chlorobenzene. The first reason is, we all know that chlorine is having minus I effect. Overall it has minus I effect. Okay, overall it has minus I effect, but it also has what? It has lone pair, 3 lone pairs. So it is also having plus M effect. Okay, so it is also having plus M effect. So now what happens here the plus M effect is not operative. Why? Because there is no conjugation, so no plus M effect, no resonance. But here you see the resonance happens, isn't it? So due to this, the structure looks like this. Now what happens, since the lone pair is in dissonance with this double bond, so this single bond gains this partial double bond character. Also there is the electron cloud is in resonance, so it's donating its electron, that means it gets partial positive charge and it's pushing electrons towards the ring. So all this position they get what? This position del negative charge, again this position, right? So this CCl bond gets partial double bond character. Now double bond, to break the double bond is very difficult compared to single bond, right? It's another thing. Okay, now since it gives this double bond character, where it is this pure single bond, here it is pure single bond. That's why, and we all know in the double bond there is better overlap compared to a single bond, and since there is a better overlap in this double bond, so the bond length becomes what? Bond length shorter. So this is the reason this CCl double bond becomes what? It is shorter also. Now this question might come in an exam, that which CCl bond is more shorter. So there is another question. Okay, another question solved here. So here CCl bond is shorter. Okay, so here now back to dipole moment question. So here it is completely towards chlorine because there is no plus M effect is operating. So it gains completely this del negative charge and this is del positive. But here inductive effect operates. But here also it counteractive this resonance takes place. That's why ultimately it partially becomes neutralized. That's why here the double bond is less compared to this. This one is purely towards chlorine, right? So this is the first reason. Now the second reason, if you see that here it is cyclohexyl chloride. Okay, now here it is chlorobenzene. Now see this center, this carbon center, here it is sp3 hybridized carbon, but here it is sp2. Okay, so sp3 hybridized carbon means what? This is having this less s character, right? Because it is having 25% s character, it is having 33% s character. So less s character, less electronegative, isn't it? So this sp2 hybridized cis bond, it is having, this carbon is having less tendency to release electron toward chlorine because it is electronegative, right? It tries to slightly withdraw electrons towards itself because it is comparatively more electronegative carbon than this, right? So there is a basic condition. On the other hand, chlorine is electronegative, it tries to withdraw electron towards itself, and this carbon is also like, no, I'm not going to lose all my electrons, I'll also try to pull some of the electrons towards myself because I'm also electronegative. So there is a basic condition, whereas it is less electronegative, so it's completely towards this chlorine, isn't it? So that's the reason this is the dipole moment of cyclohexyl chloride is more than chlorobenzene. So another question is also solved. This question might come in an exam, that which cis bond is shorter. So this cis bond is shorter compared to this. So I hope you understood the questions, understood the concept behind the questions. If you have any doubt, please let me know. Thank you. Bye bye. Take care.